Welcome, guys. We're going to be going over how to conduct a one sample t interval for mu. This is going to be Unit 7, Lesson 2 in our AP Stats course. Let's go ahead and name the test a one sample t-test. If I said interval, my apologies. It's a one sample t-test. And that's going to always be for mu. See, when we're testing for averages, for trying to test for a population mean, we use the t distribution. The t distribution gives us a little bit wider interval, accommodates for more sampling variability with sample standard deviations as opposed to population standard deviations, which we rarely know. So let's suppose we have a scenario where we're trying to test to see if students are getting enough sleep per night. So this question here is recommended that teenagers get 8 hours of sleep per night. Okay, that's kind of like your null. You believe that students at Independence are getting a less than. So alternative is going in the less than direction. We want to test this belief. So we're going to take a random sample of 14 students and record the average number of hours per sleep during the school week for each. Do these data provide convincing evidence? That language right there lets you know that is going to be a test that students at Independence get less than 8 hours of sleep per night during the school week using, and they give you the alpha 0.05. So the first thing is we need some data. Well, guys, I went out and I took a random sample of 14 students, and here are the sleep that I got recorded from them. These are all in hour or half hour increments. So we have 5, 6.57, 6.58, etc. So with these 14 data points here, we're going to put this data in our calculator. So go to your stat edit and enter those 14 numbers in there. Pause so that I'm not ahead of you. And let's see if we calculate the same sample mean and standard deviation. Stat calc 1 variable stats, go to calculate. And I have about 6.93 for our sample mean and about 1.25 for our sample standard deviation. So we're going to go ahead and write those information on here. 6.93 hours and 1.25 hours for our sample standard deviation. And our n, of course, in this case is going to be 14. And we're going to use that data to run our test, see if we actually have convincing evidence that it's less than. So right now we have some evidence that it's less than because, of course, our sample mean is under 8 hours. So we have evidence against the alternative, against the null hypothesis. The question is, do we have enough evidence? Do we have convincing evidence? So let's go ahead and set up a state plan do conclude and go through that whole process here. And we're setting up our null and alternative hypotheses. We want to make sure that we have our HO and our HA set up. So our HO is going to be your default belief. And so we actually have our default belief that, of course, the actual mean is going to be 8 hours. So we say mu equals 8 hours. Now we're trying to test to see if it's less than. So our HA is going to be mu is less than 8 hours. Now let's define what mu is. So when you define your parameter, mu is going to be the true mean sleep per night for students at Independence. We also want to name our test and set our alpha level. And the problem, of course, we did that already in the previous slide here, the one sample t-test for mu. When you do the state part of your assignment, just go ahead and do that part first. Set your hypotheses, define your parameter, and state your significance level. And once you've done all that, we can go ahead and go through the steps to kind of set up the conditions. So let's go through the plan part. Now remember, with the plan, we want to check these 3 conditions. Have we met the random condition? Have we met the 10% condition? And is our distribution approximately normal either by the central limit theorem, or are we given that the fact that the population distribution is already normal, or does our data warrant being able to apply a normal curve to it? So we have a few options on that. What we're going to do for the random is we're going to go back and look at the problem. Do these data, to test this belief, we're going to take a random sample of 14 students. So we know that the random sample condition is met. So write that. We say a random sample of 14 students was taken. What about the 10% condition? Is 14 students less than 10% of the entire school population? Of course it is. So we'd write that 14 students is less than 10% of all students at Independence. But now as far as the approximately normal condition goes, we aren't told that anywhere in this problem that sleep is normally distributed. Okay, so we're not given that information, nor is our sample size big enough to really meet that central limit theorem. Okay, so remember with the approximately normal, we have three options. Here are those options. Either the population distribution is normal. Well, we have not met that condition, so we can cross that out here. Either our sample size is big enough where it doesn't really matter. We reach that central limit theorem, so our sampling distribution is going to be approximately normal anyway. Unfortunately, we haven't met that condition. So therefore, we have to graph. We got to graph our data and see, does our sample data not have any heavily skewed or major outliers? Now, the nice thing is we've already put this data in our calculator. You got it in L1. So what you're going to do is you're going to go to second y equals. Enter this in L1 if you haven't. Pause the video so you can do this with me. You go to second y equals, turn on your stat plot, and go to the box plot. Just use the box plot with the outliers shown. Make sure it's pulling from L1, and go ahead and hit zoom 9. It's going to tell you right there, just based off the way that box plot looks. And sometimes you're given a dot plot and to work with already, but in this case here, we have to sketch that graph. So what we're going to do is we're going to look at the graph of that. We're going to draw that out. It doesn't have to be anything super detailed. As long as a rough sketch of that graph is provided and you state sample data is not heavily skewed or does not have any major outliers. Now, this is what we want to report. Now, we're not even going to write this stuff here when we're doing our approximately normal condition. We're going to pick the one that applies. We're going to graph the sample data, and we're going to comment on that it's not heavily skewed, nor does it have any outliers. We're good to go, guys. So we've met the conditions for our test. We're going to go ahead and run the test. Now, for the test, if you're doing this by hand and not using a calculator, to calculate the test statistic, you're going to take your sample mean. You're going to subtract the null mean. So in this case here, our sample mean was, I believe, 6.93. Our null mean was 8. And we're going to divide that by our standard error formula. Now, this formula here is provided on your formula sheet. So make sure that you reference that when you're looking up at your AP Stats formula sheet here. So remember, let's go ahead and plug that in, see if we get a t-test statistic. I'm going to go ahead and run the one variable stats again. And we'll say 6.93. So 6.93 and 1.25. So 6.93 minus 8 divided by 1.25, and our sample size was 14. So divided by the square root of 14. Let's calculate that. And our t-test statistic is about negative 3.2. I'll say negative 3.203. And now we're ready to actually find our p-value and get all this information here. So remember, our degree of freedom is always going to be our sample size minus 1. So in this case here, it's going to be 14 minus 1, which will be 13. And I like to use our TCDF. So with the TCDF, what it's going to look like is the following. We're going to go to second vars. And we're going to go to TCDF. That's option number 6. And we're going to keep our lower negative 1E99 because this is a negative t value. So we're going to go below. So negative 3.203 is going to be your upper. Your DF is going to be 13, not 3. I don't know why I wrote 3 there. And that's going to be your p-value. So I'm going to go ahead and write a 13 there so we can kind of be consistent here. Your p-value is going to be the likelihood. If I go out, see, negative 3.203, that probability right here is going to be your p-value. So when you're thinking about the area under that t curve, that's what that represents. And in this case here, it's going to be 0.003. So let's go ahead and write this down. Our test statistic is negative 3.203. Our p-value is 0.003. And our degree of freedom is going to be 13. Now, just a quick note, if you're using the table, if you're using table B, what you're going to do is you're going to make your T star be positive, because these are always going to be positive values in here. And we're going to look at our degree of freedom at 13, and we're going to go to the closest number that represents 3.20. So if you look at your table here, I'm going to see if I can annotate over this. We're going to kind of meet this 13 here. And notice that there's two numbers here. And that 3.2, I'm leaving off the negative, so just call it positive. So 3.2 happens to fall between there. So the p-value is going to be between 0.005 and 0.0025. And our p-value was 0.003. And so you will find that that number is between those two values. So this gives you some kind of indication of the range of values the p-value is in. So we ultimately know our p-value is pretty small. And between those two numbers, we're still going to reject the null hypothesis with that small of a p-value. Now, for practical purposes, you're going to run this test using your calculator. So when you have all this entered in here and you calculate your p-value of 0.003, let's match up and see if we can run this in the correct test. So if you go over to test, this is a one sample t-test. So this is what the calculator is going to call t-test, option 2. And since we entered our data in from L1, we're going to pull it from data, and we're going to make our null 8. And we're going to pull from L1, and we're going to say less than. Remember, we're trying to test to see if it's less than 8 hours. So let's calculate that. And you should see the same t and p value that we calculated by hand. So we're going to write that down. So our t-test statistic, again, is negative 3. I'll just say negative 3.2. Our p-value is 0.003. And our degree of freedom, which is not listed, is always going to be n-1. So 14 minus 1 is going to be your df. Write that down regardless of if your calculator says it or not, because we want to make sure we're reporting that, because if we were to use that from the table, we'd have to use the line 13 on that. So what do you need for the do part? Honestly, you're going to use the calculator here, and you're going to just kind of report this information here. And it doesn't hurt if you haven't already written it down somewhere else to write down the sample mean and the sample standard deviation. So S of X is going to be 1.25 hours. But most importantly, you need a t and you need a p-value to report this information here to make our conclusion. So what's our conclusion? Well, with the p-value that low, what do we always conclude? We're going to reject the null hypothesis. So you know how to write that. So you can pause the video and try to write that on your own and check after you unpause it. And this conclusion probably matches what you have, since you're experts already at this. Since your p-value is going to be less than our alpha, we're going to reject the null. We do have convincing evidence in this case that the students at Independence are sleeping less than 8 hours each night on average. So that's your state plan do conclude procedure. Pretty simple. Once you run your t-test in your calculator, actually that part of it's pretty easy, right? These numbers here are going to come right from there. And if you're off a little bit, from what you calculated by hand, it's not a big deal. Again, I would just kind of report that negative 3.2, round it to 1 decimal place. At the end of the day, p-value is what you're going to make your conclusion off of. So let's go through what we have to know to kind of make sure that we're setting these up. And the important idea is, remember that anytime you're doing a mean, you're going to use the t-distribution. Because again, we do not know. We have an unknown population standard deviation. So we're going to stick with the t-distribution and use our degree of freedom to help determine what the, how close to approximately normal it's going to be. But remember, the higher the sample size, the more that's going to be like a normal distribution. So we stick with a t regardless of the sample size, as long as we do not know our population standard deviation. Again, when we're talking about the state plan do conclude, for the state, name your test, write your hypotheses, define what mu is, and state your significance level. For your plan, check your 3 conditions. Random, if sampling from a larger population, make sure you're not sampling more than 10%. Make sure you're hitting your approximately normal condition. Remember, this is not large counts because we do not have a proportion. So there's 3 options for the approximately normal. Are we given that the population is approximately normal? It would say it if we were. Is our sample size big enough that we can use the central limit theorem? If not, then you're going to have to graph the data, okay? We're going to have to see if a box plot of that data is not heavily skewed, nor does it have any outliers. And if you're meeting all those, you're good to go with your 3 conditions. As far as your do part goes, you can use the formula x bar minus the null mean divided by s over the square root of n. Get your p-value using TCDF or table B. Multiply it by 2 if it's a 2-sided test, and report your degree of freedom n-1. But you can also just get that information from the t-test. So remember that you're going to stat test 2 t-test, inputting your data in there. And if it's from L1, make sure you're pulling it from L1. Otherwise, you can use the inputted data from your stat that go into your stats. And make your conclusion like you normally make your conclusion. If our p-value is less than alpha, reject the null. We have convincing evidence that in context. And if our p-value is greater than alpha, we're going to fail to reject the null. And we do not have convincing evidence in context. So go ahead and try this question here. Pause the video and try it on your own, and I'll walk you through it. Okay, I'm going to read the problem. According to the National Center for Health Statistics, the mean systolic blood pressure for males 35 to 44 years of age is 128. The health director of a large company wonders if the national average holds for the company's middle-aged male employees. So the director examines the medical records of a random sample of 72 male employees in this age group and records each of their systolic blood pressures readings. For these 72 employees, the mean systolic blood pressure was 129.9 with a standard deviation of 14.9. So we're given the sample mean and the S, and I'll put a little X there for those. And we know our sample size. So we have all the information that we need to be able to run the test. And remember, we're trying to compare it to the national average, which is 128. So you know that's going to be your like mu, your null hypothesis, that 128. So these data, we're trying to see if we have convincing evidence, and we're going to use the 10% significance level to do that. Okay, here's what I got from my state. I stated that we're going to conduct a 1-sample t-test for mu. Define what mu was. It's the mean systolic blood pressure for this company's middle-aged male employees. And I have my hypotheses. Now, your hypotheses are honestly what's most important here. And because of this word different, that's why I'm using the not equal to. Okay, and so it didn't say it was more than, it didn't say it was less than, it just says different from. So even though our number here in our sample was more than, and we could have easily went into the greater than direction, the wording says different, so we want to use not equal. And notice that our alpha is 0.1, so that's not the 0.05 that we're used to. So that's going to be your state. So hopefully you're able to set those up. Go ahead and check your plan part. Pause the video and try that on your own. Okay, this part was relatively straightforward. We were given a random sample of 72 male employees. It was stated that in the problem. So right here, you can see a random sample of 72 male employees. Now, 72 doesn't necessarily meet the 10% condition for most companies, but it does say this is a large company. So 72 can be assumed to be less than 10% of all male employees at the large company. And our sample size being so large that it's going to meet that central limit theorem because it's greater than or equal to 30. So we don't have to plot the data points, even though we weren't told that the data itself is normal. All right, go ahead and run the test, and we'll go ahead and check our T and our P value. Pause the video, try it on your own. Okay, now this one I went ahead and ran in the t-test in your calculator. I'll walk you through the steps. I just went to test. This is the option 2. This is a 1-sample t-test called t-test in your calculator. Keep it at stats. For your null, just enter 128. sample mean 129.9, sample standard deviation 14.9, inner sample size of 72. And we set a two-sided, so it's not equal to. We'll go down to calculate. And here's what we got. We got our t-test statistic, 1.082, our p-value of 0.2829. I went ahead and rewrote the x bar and the s of x, and I did make sure you write the degree of freedom, even if you're, not necessarily needing it for your calculator, because it's going to be asking for that df and the do part a lot of times. So just report that degree of freedom regardless if your calculator says it or not. And we don't need to go through the formula on that. You can do that part in your calculator. Go ahead and do your conclusion. And of course, with a p-value this large, we're going to fail to reject the null hypothesis. We simply don't have convincing evidence that the mean blood pressure for these men at the company is different from 128. So we have run the test. We have made no conclusions based off of it because of our big p-value. That's okay. That happens sometimes. And so let's read through this next part here. Using the sample above, construct and interpret a 90% confidence interval to estimate the true mean systolic blood pressure for the middle-aged men at this company. The conditions should already have been checked in part A. Well, we know how to do a confidence interval. We've done those already in the previous lesson. Hopefully you remember how to do that. So go ahead and see if you can construct that interval. Don't worry about the conditions if you already did those before. And pause video, try it on your own. All right, so we're going to run that interval. I'm not going to define mu. This is the one sample t interval for mu. We're going to use the 90% confidence level. So this is, since we use t-test for one sample, we're going to use t-interval for one sample t-interval. And we're going to keep that at stats. And we already have our data from our t-test. So if you have your data already inputted from your t-test, it should automatically populate. And the only thing we want to change here is a 90%. So let's calculate that. And there's going to be your interval. So let's go ahead and write that down. So I just wrote down the interval and I did my conclusion. We're 90% confident that the interval from 126.97 to 132.83 captures the true mean systolic blood pressure for the middle-aged men at this company. And of course, if you look at our p-value being really high, we fail to reject the null. In this case here, what number is going to fall in that interval that's going to be consistent with our results? So if you look at part C, question just simply says, how are your results in the 90% confidence interval consistent with the conclusion from part A, but provide more information than that of the test? And, the way it's consistent is, of course, your 128 is in the interval. So we just want to state that, since 128 is included in the interval from 126.97 to 132.83, we do not have convincing evidence that the true mean systolic blood pressure for these middle-aged men at this company is different from 128. And that interval also gives a range of plausible values that the true mean could be. So that the interval is always going to give you more information than what the test is going to run. The test is simply to give you kind of a yes or no answer. So that kind of wraps it up. I hope that was helpful for you guys. Again, let me know if you have any questions. Thanks.